In this short video, I will talk about the difference between two concepts. And the first one is the concept of equilibrium. When we say that we have equilibrium, what we mean is that the net force acting on your system is zero. Now, if I take my system to be a mobile electron, so what I have here, this is a mobile electron, and this is just present inside a wire, inside a conductor. If the net force on this is zero, because it's a charge, the net force can be zero only if the net electric field at that point is zero. Okay, so when I talk about equilibrium in a circuit, what I mean is that there is no net electric field inside the wire. How do you do that? You just don't connect the wire to anything, to any power supply. Okay, or you only connect it to, if you want, one side of the power supply, but not both, the negative and the positive. So let me show you what I mean with that. So if I make this circuit, and let's make the battery. So this is the wire. I'm not connecting it to the if this is the positive side, that's the negative side of the battery. I'm not finishing that connection. Then I have equilibrium. There is no net electric field inside the wire. There is no net force on that mobile electron. That mobile electron is not going anywhere. That's when you have equilibrium. Now, the other concept is the concept of the steady state. Steady state means that whatever is going on now, you're gonna have exactly the same thing going on 1 second later, and 2 seconds later, and 3 seconds later, which means things do not change. Now, here is what happens. Here is how I can make a steady state. I can bring this and connect it here. If I wait for a little bit more than a nanosecond, like a little bit more than 10 to minus 9 seconds, then I'm gonna have a current, a nice current flowing in this wire. My electrons are gonna move from here, and they're gonna go this way, and the battery is gonna bring them back to the negative side, and they're gonna go back here. If you wait for a little bit more than a nanosecond, you're gonna have a nice current, constant current throughout the circuit. Now, if I do have a current, and this means that my mobile electron will feel a net force, and because it's a negative charge, this means that the net electric field is pointing to the right. Steady state means that the net electric force and the net electric fields are constant. Okay, this is the difference between equilibrium and a steady state. In a steady state, things do not change. You have a constant net electric field, a constant net force acting on the electron, and the electron is moving around the wire in the same way. In equilibrium, those concepts are zero. The net electric field is zero. The charges are not going anywhere, and you have zero net force. So it is important to remember the difference between the equilibrium and the steady state. Now, there is one more idea that we don't talk much. I said before that you need to wait for 10 to minus 9 seconds, right? I said once you make the connection, you have to wait for a little bit. This is where you are in a transient state. Okay, this is where things change. So this is where, like, the net electric field changes, the net force on your mobile electrons is changing. Things change until you get until the steady state is established. Now, things I think I forgot an H here. Established. All right. Things are fairly complicated in this transient state. Okay. We don't really, at least in introductory physics courses, and actually even in upper level electricity and magnetism courses, we don't look into much into what happens during this transient state. It is difficult to study this period of time, and maybe computations is the only way that you can really look at it. In introductory physics courses, what you need to understand is when you have a steady state and when you have equilibrium.